Hello everybody, my name is Gustavo. I'm a research fellow from Queen's University, and today I'm going to talk about our study on smart contracts. So the title is an exploratory study of smart contracts in the Ethereum blockchain platform. So a lot of words, let's break it down. So blockchain. So digital financial transactions are part of our daily lives. You can think of like Brian sending money to Emma, and then we have banks, and they basically enable these digital financial transactions. But ultimately, a bank is just a mutually trusted third party that maintains a ledger of these financial transactions. And blockchain platforms, they replace these banks. So blockchain platforms enable secure and decentralized processing of financial transactions. They remove the middleman, the banks. And then the Ethereum blockchain platform. So Ethereum is the largest programmable blockchain platform. So Ethereum is not only acts as a decentralized bank, but also as an application development platform. So you can actually develop applications and deploy them to Ethereum. So smart contracts. Smart contracts are the building blocks of these applications that live on the blockchain, and we call them decentralized applications or simply DApps. So Brian, he can trigger the sell my meme function from a DApp, and a DApp is composed of smart contracts. And you can think of smart contracts as kind of like classes in object-oriented programming. And the smart contracts, they are hosted by and executed by Ethereum. And despite the name, smart contracts are just kind of general purpose computing programs, and Solidity is the most popular language. But what we see now is this beautiful marriage between software engineering and blockchain technology, because Ethereum is this novel application development platform. So an exploratory study, finally. So why an exploratory study? So first, we saw a lot of hype around blockchain technology. So it's very difficult to know like what is real, what is not real. We saw applications that sell digital collectibles like cats. And we saw digital cats being sold for more than $100,000. And you can actually go there and check these transactions, so they're real. And second, we also saw that some studies were investigating very detailed aspects of smart contracts like security. And we felt that the very basic characteristics of smart contracts were still known. So what do they do? These contracts, are they complex and stuff? So we were interested in this basic characteristics. So in our exploratory study, we focused on three very basic aspects. So activity level, categories, and code complexity. And this is the data collection diagram of our study. And the purpose here is just to show that we got data from several sources. So from Google BigQuery, from Etherscan, which is like an analytics platform for Ethereum, CoinMarketCap website, and the State of the DApps website. So the State of the DApps is kind of like an app store for DApps, for applications that live on the blockchain. So ultimately, we did MSR applied to blockchain repositories. So in terms of activity, so activity level is concentrated on a very small subset of the contracts, and almost 3/4 of these contracts are verified, so their source code is available on Etherscan. So if we compare this percentage of contracts with the percentage of received transactions, we notice that 0.05% of all contracts received 80% of all transactions sent to contracts. So a tiny percent of the contracts received the vast majority of the transactions. And our point that we discuss in the paper is that new solutions to cope with Ethereum's limited scalability should take the activity imbalance into account. In terms of the category, so we saw that most of the high activity contracts were mere token managers. They were basically just managing the coins with functions like withdrawal and transfer. So in this table, we have these high activity contracts and the DApps that they belong to and the category of these DApps. So we see that the majority of these contracts are associated with DApps that are currency exchanges or that deal with financial transactions somehow. So 8 out of the top 10 contracts with highest activity belong to currency exchange DApps. So our point is that the new widely advertised rich programming model of smart contracts is currently being used to develop very simple applications that tend to be financial oriented. In terms of the source code, we saw that high-activity verified contracts, their source code tends to be small, commonly uses at least 2 code blocks, and is extensively documented. So in terms of documentation, so this is the comment ratio, so just a comparison between lines of code and comment lines. And we compared this comment ratio across languages, and we saw that in Solidity, the comment ratio is much higher. So more specifically, the comment ratio in high-activity verified contracts is higher than that of GitHub top-stack projects written in Java, C++, and C#. And our key point here is that the source code of high-activity verified contracts, they exhibit unique complexity characteristics compared to code written in traditional programming languages. So after doing this experimental study, we came up with an open research agenda with open questions. And here are 3 of them. So first one is, why are there so many low-activity contracts? So are they just toy contracts, or are they actually relevant read-only contracts? We don't know. Why do high-activity contracts capture a very limited number of use cases? Is there any problem with the technology, with smart contract technology per se, or is it something else? We don't know. And why is the source code of high-activity verified contracts so extensively documented? Like usually in traditional programming languages, when you have code that has too many comments, it's usually a sign that the code has problems. It's difficult to understand the code. But here it seems to be a little bit different, so we don't know yet. And there's still a lot to be done in the field. So now we're seeing this memes being sold for like $400,000, and an artist just sold this JPEG file for $69 million. So it's a very interesting field. There's still a lot to be done there in terms of software engineering research. Here I conclude my talk. So I showed that Ethereum is the largest programmable blockchain platform. In this exploratory study, we focused on understanding the activity level, the domain categories, and the complexity of the code of smart contracts. And we observed that new solutions to cope with Ethereum's limited scalability should take the activity imbalance into account. This new rich programming model of smart contracts is currently being used to develop very simple applications. And the source code of high-activity contracts, it's unique. It has different complexity characteristics compared to what we normally see in other popular programming languages. And then we came up with this open research agenda that has 10 open questions for future studies to investigate. So thanks very much. My name is Gustavo. Here's my website. Please feel free to contact me. Thank you very much.
Hello again. The last paper of this session is called An Exploratory Study of Smart Contracts in Ethereum Blockchain Platform. The author is Gustavo Ansaldi Oliva. He is here with us to answer any question you would like to ask. So please use the chat you have on the right of the window to ask any questions you would like to ask. So the first question for me is that the study period is from July 2015 until September 2018. So what might have changed during this period?
That's a very good question. Things are evolving pretty quickly. It's difficult to know, like exactly. I think we would need to collect data again and evaluate things again. But my gut feeling is that the applications are getting more complex. We're seeing a lot of industry segments that are really interested in blockchain. So I would assume that the characteristics of some smart contracts and some decentralized applications would be a little bit different compared to what we found before. So yeah, it could be a little bit different. I don't know exactly if it makes the validity, if it's a threat to the validity of the paper. I think the paper represents the situation as it were back then. So I think actually this was the very first empirical, quantitative empirical study on Ethereum published in a good journal. So yeah, I hope to see new papers soon about this topic.
Thank you. We have another question from an attendee in the last part of the chat. He's asking, what do you think are the main SE-rated challenges that are specific to NFTs?
Non-fungible tokens. Yeah, so that's an interesting question. I don't know. I think a key challenge is, so with NFTs, it's all about proving that you own something, right? So people have used blockchain now to as an infrastructure that they can leverage to prove that they own something. So they own that video, they own that picture, right? So I think all the aspects that were discussed around vulnerabilities and security, I think they are really important in this when you talk about NFTs, because if someone can exploit a contract and for instance change the owner of a given NFT, then this would be a big problem. So I think vulnerability and security aspects are a key thing when it comes to the development of smart contracts for NFTs. But it's difficult to get it. It's very new. So the NFT thing is a boom that is happening like this year and started, I guess, last year more strongly. So it's still very early, very new, but I would say that the security aspect is always going to be a very important thing, especially in the NFT domain.
Okay, thank you. Other question is that, as you comment, despite the name, smart contracts are general purpose computing programs. As they are mainly used to develop simple applications that exhibit unique complexity characteristics, a model-driven development approach could fit
This paradigm. Yeah, so it's a very interesting question. I haven't seen much work in the MTT domain. I have seen people doing validation and verifiability of contracts and that kind of stuff. I think the closest I've seen, and I think it's from a practical perspective, it's really important in this domain, is the use of template contracts. So the idea is that you don't want to have bugs in your smart contract because, again, you can lose a lot of money and stuff like that. So people, and we still don't have a central repository like NPM or Maven, right, for smart contracts. But we do have a few groups that audit contracts and they provide contracts to be reused. And a lot of these contracts are kind of like templates where you just fill in with your information. So this notion of reusing templates is something that I've seen in practice, but I haven't seen specifically MDD, so like tools where you would build workflows and drag and drop things. I haven't seen much. There could be, maybe I'm not familiar and I don't know, but I haven't seen, to be honest.
Okay, thank you. Other question is, what do you think that the existing programming model of the smart contract is being mainly used for developing very simple applications? Is it explained by potential limitations of the technology, or is it just due to characteristics of the application?
Oh, interesting. Very good question. I think and this is, again, just my very subjective opinion.
Yeah, of course, no worries.
I think it's a combination of multiple things. So one, the technology is pretty new. So smart contracts, Solidity, the way Ethereum works. So you don't have as many developers. You don't have you have very big Java communities, JavaScript communities, and with Solidity and smart contracts, it's a little bit different. So you don't have such a big community around it. It's getting bigger and bigger, but it still doesn't compare to the communities you have in other languages. So I think this is one explanation. The other thing too is there, as I try to say, I think there's still a lot of hype. So when blockchain first appeared, like people thought they would solve all world problems using blockchain, right? And then they started facing the limitations of the platform. So it has scalability issues, for instance. So again, I don't think you can do everything with blockchain, just like you shouldn't do everything with cloud computing or everything with service-oriented systems, right? It probably fits some use cases, right? And So you don't have as many developers. The language is still evolving. The development environments are also evolving. Again, for other languages, you have things like Eclipse and Visual Studio where you have a lot of support, a lot of debugging tools. And I think the other presentations, they touched on that a little bit. So I think it's a combination of multiple things, a lot of hype. I think now we're starting to see bigger applications, more solid applications. So it would be kind of interesting if anyone is willing to replicate the study and see what's changing. That would be pretty interesting. Again, our idea was, people were doing a lot of stuff with security and all that, and that's very important, of course, but our idea was, let's take a step back, see what's happening, see what people are using smart contracts for and all that. So it would be interesting to see someone rerun the study in the future. Who knows?
Okay, thank you very much.
Thank you. Thank you.
So if there are no more questions from the attendees, we can finish the session here. This is the last paper of the session, so we can go on with the other session. So receive a virtual clap for all the attendees.
Thanks a lot. Thank you. It was a pleasure to be here.
You can continue. If any attendee has more questions, you can go to the discussion room.
Sounds good.
Bye-bye. See you.
Bye. See you.